Small language models create and use security risks. Edge AI will improve performance, reduce power, and keep data local, but risk equation changes. The rollout of Edge AI is creating new security risks due to the mix of small language models, SLMs. Their integration into increasingly complex hardware, the behavior and interaction of both over time. AI data centers will garner the most attention due to the massive investment and the ongoing flood of deals and acquisitions, but the edge is quietly starting to take shape for several regions. It has too much energy and too much time to send data to the cloud and back, and it is easier to secure data if it remains on-premise. As a result, more localized compute capabilities are being implemented across a new broad swath of vertical market segments, opening up a new opportunity within and alongside those markets and scaling down language models for both training and inference. Small language models have started to become more capable, said Niranjan Chittapure, a group product manager of generative AI at Siemens Digital Industry Software. The voice models on your phone, or even small image models, can make small changes, and a few months back, we saw the first few series of small language models that can do listening, which is required for math and coding. In general, the edge is considered anything outside of the cloud, although definition and boundaries are fluid. Edge devices include everything from large on-premise data centers to ADAS-enabled cars and smart doorbells, and SLMs and the scaled-down LLMs are being developed are fully finally to do these different segments. The SML space is now getting so crowded as the LLM space, and the reason is that they have very task-specific, said Sitapur. One of the challenges is orchestration and at a broader level, how people think about which models should be used or fine-tuned for a specific task on their device. For example, SLMs have multilingual capabilities, and so do you prioritize a model that is multilingual in 5 languages or 50 languages? Those decisions have started to become more complex as the model space gets more crowded, or the wattage gets constrained. This has broad implications for both hardware and software security. SLMs can self-optimize, update, and interact in novel ways, and they can interact with other SLMs on the same or different devices. That, in turn, widens the attack surface in unpredictable ways. So while automakers have committed significant resources to ensuring the security of the safety critical systems, security is far less constant for SLMs used in IoT devices and other emerging markets. When you move out of the data center, putting models and all of the compute on people's devices, then for the most part we no longer have professional IT management providing perimeter defenses that you have the server deployment. Sadadana Neustadter, Senior Director of the Product Management of Secure Life Solution at Synopsys. Coming up with a specialized model is in reality expensive because you're taking the datasets, customizing them, and in some cases retaining them in augmenting forge of the training of the datasets. Moreover, because these markets are so different, there is a little overlap in models today. There isn't the notion of the economizing to build a shared model with the augmented views, which allows you to recognize on the data to create a fairly complete but general models and then the highly trained augmentation of that for particular purposes. Those starter said in order to keep themselves isolated and behaving as they were intended by their developers, so you need to have a strong isolation and platforms. There's also benefits to doing that hardware, particularly as you get into things that are more safety and critical for protection of data. It's a bit like having a single key vault in a mobile device. You know the keys are for different domains. You depend on the application to keep them separate from each other. The competition to be the first to market with new language models is the last intention that in the AI data centers. As with the LLMs, the speed of delivery for SLMs is far outpacing the ability to develop standards, regulations, or even best practices. There is at least some general understanding of what needs to be done, what the potential security holes are, and how to address them. Security frameworks and AI systems are evolving, said Eddie Ramirez, Vice President, Marketing in ARM's Infrastructure Business. We've spent a lot of time at ARM for and confidential computing. Well, the goal is to ensure that you're driving security at the virtualization level. Anything that's virtualized has its own memory space and that's encrypted, that it has its own keys. Another process won't ever been able to see what this is one process does in a virtualized, containerized world which preventing the leakage. Others agree. In terms of productivity maturity, it's gonna go through a lot of stringent tightening up, said Amber Borkar, automotive segment senior director of for DSP product management and marketing at Cadence. You'll have a trusted island or domain that has a memory mapped to area that you can access and the device I can't talk to or the application that are not secured. Or if you don't have a security bit enabled, then you can access certain points of memory and the evolution of the data models. There are probably going to be a framework in place for that. If these devices are learning, can they co-run? Can they share the learning between each other? Security privileges will assign to their specific models. They might be controlled by different types of vendors. The guys who generate the models or know not be able be devices itself, well, they have a certain level of the privileges what they can access that they can't tutor each other. We are already seeing that now because we have access to Copilot with Office, Word, or Outlook. In some cases, they were allowed to interact with the other models, and every day the responses are slightly different. Protection against what? A big problem for SMers in particular, AI in general, is the use of the localized AI. Much of the focus so far involves shrinking language models to several billion parameters or less in order to be able to run them on battery-powered devices. In many cases, security is a secondary concern. The guardrails that exist today, such as Mitra, as common weaknesses in a moderation list, are a good way to identify known vulnerabilities. But in many cases, they don't apply to small language models or to encryption algorithms developed for edge devices that are supposed to be resilient enough to withstand post-quantum cryptography, which will be essential for devices that are expected to be in the field for a decade or more. A major CWE list keeps growing, said Scott Bass, the senior director of Silicon Security Product and Lambas. If you dig into some of those CWEs to some degree, they end up becoming a description of a symptom and another problem solved, so it's difficult to navigate the CWE list and said, does this apply to the chip or product I'm delivering to my customer? Our customers want to know, and we definitely have some that ask how our security IP performs against the Meteor CWE list. We tell them that 80% of the CWEs on the hardware side do not apply at the IP level. If I'm delivering a block that is going to accelerate the lithium, oh, there are very few CWE that even apply at the level of the granularity. So, and if you tell them 68% of the CWEs don't apply, then they assume you're self-scoring at 30%. And once a cyber attack reaches security, there are multiple options for attackers. They can insert malware into a system to shift its behavior, which is particularly concerning when it comes to autonomous vehicles, drones, or humanoid robots. They also can steal data, whether that's data collected through the sensors or training data for SLM. Security and safety are big problems, said Ram Rajan, Vice President of ML SoC Platform Architectures at SEMA. We do a lot of encryption to make sure the weight in the DRAM cannot be explored or decrypted. You want to make sure that somebody don't steal your weight. But there's also information coming in through the sensors. How do you protect those and make sure they don't get tapped and diverted into your cloud? So there's ways of security, there's data security, and that every time we look at this, there's a penalty to the cost, the power, and the performance, so that they have to be balanced against all of this. Moreover, the typical assumption of how people interact with the machine is changing. The goal is for the machine to learn, not for a human to learn how to use it. One of the benefits of the all language models, a large small edge micro, is to change the input and the text code to natural language and the gesture. The second, I have to learn as a human how to use these things because it's a static model that maybe was trained on a data set that does operate or speak the way I speak or move the way I move. Then I have to change my behavior to interact with it, said Steve Tatalogian, Senior Vice President of IoT Consumer and Industry MCUs at Infineon. The human one learning. We really want to get to the point that is machine learning about what's important to the human or how the human interact with it and makes the experience easier. But that also opened the door to evaluate different kinds of tech. Infineon, as its recent October tech conference showed off a humanoid robot that could, with the minipet, exactly copy the voice patterns and the intonations of a person it converses with. Added to all of this to the relationship between the size of language models and the accuracy of the result, which can create different kinds of security issues. As language models LLMs are shrunk down to the fit inside the edge devices, or smaller models are developed for specific domains and workloads, and the potential for errors increases. SLMs, by definition, are less accurate than LLMs, often based on the FP16 or FP8 versus FP32 for the LLMs. That allows them to run on mobile devices powered by battery. But the quantization takes a toll on accuracy. Taking responsibility. One of the big changes involves responsibility where there is a successful attack. The EU Cyber Resilience Act, for example, imposes huge fines for failure to comply with the regulation involving either hardware, software, or both. And OPC Safe shifted the security burden on the makers of processors prefers with updatable software. This effort basically amount of the shift left for system security, which already is underway in the automotive sector. There are three key elements in automotive, said Mark Sadughetti, Vice President of Product Management Data Application Engineering at Synopsys. On the edge of the cars and robots, you need a safety aspect with the safety island. The second piece is that you need to bring your AI capabilities into your product. And the third one is that you need to secure all of that. With these three areas, you go from architecture to validation to things like over-the-air updates, which they are trying to do in an automotive market or any market. That's the purpose of software-defined product. You need to have that security, and that security has to impact the models that are being used in those edge devices. In addition, while there is a tendency to think that every edge device needs SLM, that is already best approach. There are two elements here, said Satish Ganesan, Senior Vice President and General Manager for Intelligence Sensing and the Chief Strategy Officer at Synaptics. For sensing, many of solutions like smartphone and PCs have an application processor in there. It may be from TI, Intel, Qualcomm, or somebody else, but for those particular items, it's about how to make the human-machine interface more intuitive and not necessarily with the SLM. An SLM can run on the application process, but that's different than what we're talking about with the AI native processing, like with our Astra, where each main processor on the design and robotic arms. And examples of that are where you are going to have workload of specific controls. Mechanism, those small language models that many have 70 billion parameters versus trillion parameters in an LLM. And that's just where you train it on various specific tasks. So if you have a cobot that's doing a pick and place in automation lines needs to send something else different, you give it instruction. That's the difference using automation in industrial setting today. SLMs are very workload specific. The future. The proliferation of the SLM is already underway, but the biggest changes in the US are yet to come, and the industry needs to start planning for them. Once language models start training themselves and prioritizing information that they see, that's the start of the autonomous AI thinking for itself and behaving according to its own needs. It's not just Nostr said. Neustadt said at the point, we are into a realm of a new kind of life form that is behaving in its own light. It has its own goal-setting capabilities. It's able to do what it needs, and it has kind of a ruthless logic-based ethos. There's several technology generations down the road, and the interim, you really want to ensure that the data being used to train the things is authentic. You don't want it training on its own hallucinations or whatever it's being fed by somebody who is aggressively trying to train it in a particular direction. And you have very big concern on the integrity of all the data and the integrity of the paths to training of the data back to the training engines. Today, software patches are frequently added onto one patches through a new over-the-ear software release, such as application updates on a smartphone. But as SLMs learn, they also change. So what is needed for a patch today may be different than what is needed in the future and may vary from one user to the next. SLMs effectively spelling up to the ability of a system or hardware and software to react to changes, but the flip side of that is organizations need to be able to react with the necessary levels of specificity. And while regulations attempt to hone in on best practice for security and standards seek to define them, this is likely to be a moving target for foreseeable future. Okay. I read this article. Small language models create new security risks. Thank you for your time. See you next time.